Hi, today we're looking at Functional Skills Maths Level 1. We've got the Pearson Edexcel exam board, set 9 of their past papers, and we're going to start with the non-calculator section. Question 1. A. Work out 35 squared. So 35 squared means 35 times 35. Okay, so couple of different ways we could do this. I'm actually going to do it using the grid method. So when we're doing the grid method, we're going to split each of the numbers into its tens. So the 10 is a 3, so the value of the 3 is 30. So we're going to have 30, and then the units are 5. Okay, and that's this number. And because we're multiplying it by the same number, we're going to have the same up here. So with this grid, what we're hopefully going to get is a number here, 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 and here. And when we add them all together, it's going to give us the answer to this. Okay, so first we're saying, well, what's 30 times 30? Well, let's ignore the zeros. 3 times 3 is 9. And then just put the 2 zeros on afterwards. So for here, we want 30 times 5, or 3 times 5. We've got 5, 10, 15. And then stick the 0 on the end. Now we've got 30 times 5 again for here, so it's going to be the same as before. It's going to be 150. And what's left here is 5 times 5, which is 5, 10, 15, 20, 25 to go here. So we need to add them all up. So we're going to have 900, 150, another 150, and then 25. So lots of zeros plus 5 will be 5. We've got 0 there. 5 plus 5 is 10, plus 2 is 12. So 2 carry the 1. 9 and 1 is 10. Another one is 11. And the carried 1 gives us 12. All I'm going to do is put my comma in here. So we've got an answer of 1,225. And we can pop that in here. Okay, then for part B, we've got write 325 grams in kilograms. So we need to know how many grams there are in a kilogram, and there's 1,000 grams in 1 kilogram. So if we've got 325 grams, if it's going to kilograms, it's going to be a smaller number. So we want to be dividing by the 1,000 to make this something smaller. So we think, well, where would the decimal point be? Well, this is a whole number, so we've sort of got like an invisible decimal point here, really. And because we're going to be dividing, so this is telling us we're going to need to divide by 1,000. So dividing by 1,000, we've got 3 zeros with 1,000, so we're going to move the decimal point 1, 2, 3 places and put the decimal point here. So in other words, our answer is 0.325 kilograms. Question 2. Carla needs to fill her car with diesel. She sees the price of diesel in a service station. And we've got diesel, 160p per litre. Write the price of diesel in pounds. Okay, you might be able to do this straight away, but this is similar to what we did before. We think, well, how many pence in a pound? Well, I know 100p is £1. So what I need to do with this is I want to divide it by 100. Okay, and if we're dividing by 100, we've got the 160. Again, we've got a visible point there. Because we've got 2 zeros this time, move it twice, so we end up with £1.60. Okay, we need the 0 at the end. We don't want £1.6, £1.60. 2 decimal places when you're dealing with money. And then we're told Carla needs to buy 30 litres of diesel. And diesel costs 160p per litre, as we saw before. She has £40. Does Carla have enough money to buy 30 litres of diesel. Right, so what we want is we want the 160p times 30 litres. Okay. Well, what we can think, if you think we want 160 times 30, but actually let's ignore the zeros for now. Okay, we can put them back in afterwards. So if we just go with 16 times 3, we can say, well, 3 times 6 is 6, 12, 18. And 3 times 1, or 1 times 3 is 3, plus the 1 is 4. Then we need to put our zeros back on, so 1 and 2. So a 0 there and a 0 there. We put one on the answer. So we've got, this would be 4,800, but it'd be 4,800p. It would be pence, because remember this was in pence. So if we want to make it into pounds, well, remember we need to move the decimal point 2 places in, so it actually makes it £48. Okay. This is how much it's going to cost. She's only got £40. Well, this is more than 40, so has she got enough? No, not enough money. Okay, let's straighten this up. Question 3. Kira wants to be an apprentice. She wants to apply to the company that has the greatest number of apprentices. Company A has 80 employees. 20% of the employees are apprentices. Company B has 300 employees, and 5% of the employees are apprentices. Which company has the greatest number of apprentices? Well, let's start with Company A. So we know it's 20% of 80. Well, let's start off with, what's 10% of 80? Well, if you want 10%, dividing by 10, or you're just taking off a 0, so it's just going to be 8. So if we want 20%, well, 20 is 2 lots of 10. So 20% of 80 is going to be 8 times 2, and 2 8s are 16. Okay. Now we want to do the same thing for Company B. Company B has got 300 employees. We want to know what 5% is. So again, I'm going to start off with, well, what's 10% of 300? Well, again, we just take a 0 off. So it's going to be 30. Now 5%, this time, so we don't want to double it this time. We doubled because 20 was double 10. 5% is half of 10. So we want half of 30. So 5% of 300 is going to be 30 divided by 2. Now if we do this with the bus stop method over here, we can say how many times does 2 go into 3? Well, it only goes in once with 1 remainder. How many times does 2 go into 10? 2, 4, 6, 8, 10. That's 5 times. So half of 30 is going to be 15. So we're comparing which is the greatest number, 16 or 15. So we can say, well, 16 is more than 15. So Company A. And we can put Company A in the answer box there. Then for part B, they want us to use a reverse calculation to show a check of our answer. Okay, well, I suppose when we were working before, we can pick part of what we did. So if you remember, the first thing we did was we said, well, 10% of 80 was 8. So we can do that in reverse. So we start with the 8. So well, the opposite of, well, I suppose 10% of, we were doing sort of 80 divided by 10. Well, we can say, well, 80 or 8 times 10 is going to take us back to 80. So anything like that, just looking at what you did, do it backwards. That's what they want for a reverse calculation. Okay, we could also have done something, or if you remember when we had our 10% of 300 was 30, we divided that by 2 to get 15. So we could say, well, 15 times 2, and if we quickly check it, 2 times 5 is 10, 2 times 1 is 2, plus 1 is 3, is 30. I think I probably prefer this one actually, but either one is fine. You're doing a reverse calculation. Okay, question 4. The distance between Calais and Nice is 1,195 kilometres. I'm going to put my comma in there, make it easy to read. Write 1,195 in words. So 1,000. So that's why it's helpful to put the comma. So we just look at the digits that are together. So use the comma to separate them. So we've just got 1 and it's 1,000. And then with three numbers, we've got 195. So 100. And 95. So 1,195. Three friends will drive a total distance of 1,225.3 kilometres. They will share the driving equally. They estimate each person will drive 295 kilometres. Use estimation to work out if each person will drive 295 kilometres. You must show your working. Right, we're estimating, so that means, well, for 1,225.3, what's that close to? Well, and I'm going to do a wiggly line there, so approximately equal to, well, if you're going to round, you might as well round it to a nice, easy to use number. I'm going to round it to the nearest 100. So I'm going to say that's close to 1,200. Okay. So what we want to do is we want to take our 1,200 and divide it by 3. So if we use a bus stop method, does 3 go into 1? No, it doesn't. What about 3 into 12? 3, 6, 9, 12. That's 4 times. 3 into 0 is 0. 3 into 0 is 0. So we've got 400. Okay. Well, 400 is not equal to 295. In fact, it's not even close. So we can just say no. And that's the end of the non-calculator section. So now we're going to have a look at the calculator section. If I can get my pages straight. Okay. Question 1. Marlene competes in sprint races. She wants to qualify to race in a team. Here are the times in seconds of her last 4 races. So we've got 24.9, and that's seconds, 23.07, 23.7, and 24.54. Marlene needs the mean time of her last 4 races to be less than 23.9 seconds to qualify. Is the mean time of her last 4 races less than 23.9 seconds? So for the mean, we want the total divided by the frequency, or how many. So for the total, get your calculator. Don't be tempted to do it by hand because it'll just take you a lot longer. So 24.99 plus 23.07 plus 23.7 plus 24.54 equals 96.3. And how many? Well, it was 1, 2, 3, 4 races, which gives us 24.075. Now she wanted to know if the mean time was less than 23.9. Or we can say 24.05 is greater than 23.9. So no, it's not less. Question 2. Rio has a mobile car wash business. He has a tank for water in his van. The tank is in the shape of a cuboid, 0.9 metres wide and 0.9 metres long. When full, the water in the tank is 0.4 metres deep. Rio uses 45 litres of water to wash each car. And we're told 1 metre cubed is 1,000 litres. Rio thinks there's enough water in a full tank to wash 8 cars. Is Rio correct? Show why you think this. Right, well, it might be good to try and picture what this tank looks like for starters. So it's a cuboid and it's 0.9 metres long. 0.9 metres wide and 0.9 metres long. So it's going to be, well, I suppose sort of like a square for the base. Something like that. And it's 0.4 metres deep. So something like that. Okay. So we've got that this is 0.9 metres. This is 0.9 metres. And this height here is 0.4 metres. Let's pull it down a bit so you can see the full sketch. Okay. Right. So what we're trying to work out really is what's the volume of this, turn it into litres, but also we're going to need to know how much water we need to wash 8 cars. So I'm actually going to start with this because this might be the easy bit. Rio uses 45 litres to wash each car and he's got 8 cars. So we can say, well, we want 8 times 45. That's going to tell us how much water we need. So 8 times 45 is going to give us 360 litres. That's needed. Okay. Now we've got to know how much water we've got. Well, to find out in there, I said we want the volume. The volume is the length times the width times the height, which in this case is 0.9 times 0.9 times 0.4. Which is 0.324, that's metres cubed. Right. We were told that 1 metre cubed is 1,000 litres. So if we've got 0.324, well, we want to multiply that by 1,000 to tell us how many litres it's going to be. And that's 324 litres. Okay, so we've got 324. We need 360, so we can say 324 is less than 360. So not enough. Rio is incorrect. Okay, question 3. Ella is making a path around 3 sides of her lawn. The lawn is in the shape of a rectangle. So here's the path here, here's the lawn, sort of in the middle. The width of the path will be 1.2 metres, so that's here, that's going to be here as well, and along here at the bottom. All corners of the path are right angles. Ella will cover the path with gravel, and gravel is sold in bags. Each bag of gravel covers 3 metres squared. Work out the number of bags of gravel Ella needs to buy to cover the path. Okay, right, so move that back down again so we can see the full question. Right, so we want to know really what the area of this path is. So it might help if we split it up into rectangles. So we've got one long rectangle here, which is 1.2 metres by, well, this distance will be the same as this one, which is 15 metres. So we can say the area will be the length times the width. So 15 times 1.2 gives us 18 metres squared. We want the area down here as well. This is going to be the same. It's also 18 metres squared from up here. And finally, we've got this rectangle here. Well, we know that the width, this is going to be 1.2 metres, but it's this length that we want. Well, we know the whole thing is 9 metres, so we're starting with 9 metres, but we want to take off 1.2 metres at the top, and then we want to take off another 1.2 metres down here. So if we do 9 minus 1.2 metres, and then minus another 1.2 metres, we get 6.6 metres. Okay. You could add the two 1.2s together and take them off in one go. It's fine, you'll get the same answer. So we've got the area of here is going to be our 6.6 metres times 1.2 metres, which gives us 7.92 metres squared. Okay, so the total area of the path is going to be 18 metres plus another 18 metres plus, sorry, not metres, metres squared. So 18 metres squared plus 18 metres squared plus 7.92 metres squared. So we've already got the 7.92 in there. We can add in the 18 and another 18. So we get 43.92 metres squared. The gravel is sold in bags of 3 metres squared. So we want to divide that. So we're going to do our 43.92 divided by 3. That's going to tell us how many bags, which is 14.64 bags. You won't be able to buy 0.64 of a bag, so we're going to have to buy 15 bags, because 14 wouldn't be enough, so we have to go up to the next whole number. Okay. Question 4. Colin wants to buy a new television. He sees this offer. Television, normal price £599, now 35% off the normal price. Colin uses the offer, work out the price of the television using the offer. So what we want to do is work out what 35% is and then take it away from the original price. So for 35%, we want 35 divided by 100 and multiply it by the 599. Which gives us £209.65. So that's the money off, so we need to take it away from the 599. So 599 minus £209.65, and we get £389.35. Question 5. Jessica wants to sell her house. She has this information about the selling prices of houses in her street. So we've got one was for 199,000, one for 195,500, another for 225,550, 190,995, and £229,000. Okay, Jessica thinks the range of these selling prices is more than £35,000. Is Jessica correct? Well, if you want the range, you need the biggest, and from that you take away the smallest. So if we look at which of these is the biggest number, well, we've got 225,000 and 229,000. So this is going to be the biggest. The others are all below 200,000. So which is 199,000, 195,000, 190,000. So, and that's the smallest. So we want 229,000 minus 190,995. And we've got a range of 38,005, and that is more than 35,000. So yes, she's correct. Now, we're asked to show a check of your answer. Okay, well, what you want to do is start with your answer, which was the 38,005, and we took off 190,995, so we're going to add back on 190,995. So we've still got that in the calculator, add on 190,995, and we get back to 229,000, which is what we want. Let's see if we can get as much of the question on as possible. Question 6. Write 35% as a decimal. Right, well, 35%, you want to do 35 divided by 100. So 35, you can think of a decimal point at the end. Dividing by 100, we're making it smaller. And we've got 2 zeros, so move it once, twice. So we're going to get 0.35. Peter uses a map to plan a route for walking. The route he will walk today is 14 centimetres on the map. 1 centimetre on the map represents 2.5 kilometres on the route. Pete uses this rule to work out the time needed to walk the route. So he takes the distance in kilometres, divides it by 4, adds 0.75, and that gives him the time in hours. Work out the time needed to walk the route. Give your answer in hours and minutes. Right, so to use this formula here, we need the distance in kilometres though. At the moment we've got it in centimetres, but 1 centimetre is 2.5 kilometres, so 14 centimetres is going to be 14 times 2.5 kilometres. Oh, which is, let me show you that again, it was off the screen when I did that, times 2.5 gives us 35 kilometres. So we can plug that into here. So we want 35 divided by 4, which gives us 8.75. Then we add on 0.75, which gives us the time in hours, 9.5. They want us to give the time in hours and minutes. Well, that's going to be 9 hours. Well, 0.5, that's half of an hour. So it's going to be 30 minutes. Okay, if you want to check that, you can take off the 9, because we know that's the hours. 0.5 of an hour. We know there's 60 minutes in an hour, so multiply it by 60. That gives us our 30 minutes. All going well. So, question 7. Here is a cuboid. It's got the length is 6 centimetres, the depth is 3 centimetres, and the height is also 3 centimetres there. Draw a net of the cuboid. Use the centimetre grid below to draw your net. Okay, so a net, we're going to take the shape and we're going to flatten it out. Okay, now what I'm going to do is I'm going to sort of draw in what we can't see, make it look a bit more sort of 3D. So that would be the actual shape. So if you think we've got a base, we've got a front and a back, we've got a top, and we've got 2 sides. So think of the bottom first, or base. Yeah. Then this side, or this front, would flop down. That would be our front. The back would flop up. And then the top would be connected to the back. And these 2 end bits, or side bits, would stick out like that. Okay, so this is just a sketch, but it's going to help us for when we're drawing it. So we know that these bits are going to be 3 by 3. And all of these rectangles are going to be 6 long and 3, 3, 3, and 3. Okay, so that should help. So if we're drawing this on here, I'm going to think, well, where shall I start? Let's go somewhere in... we need 4 of those rectangles. Well, actually, we can just work it out. Let's start with the top up here. We need it to be 6 centimetres across. So maybe start here. 1, 2, 3, 4, 5, 6. And 3 centimetres down. 1, 2, 3. So let's do the same on this side. Just doing the lines a bit darker so you can see it better. Okay, so that's going to be our top. Then we need these other 1, 2, 3. And 1, 2, 3. Okay, so I'm just doing this for you so you can see it better. Right, so we've got 1 rectangle, 2 rectangles. If we look back at the sketch, I needed 1, 2, 3, 4 of these. So 1, 2, 3, and 1, 2, 3. Now these drawing ones can be quite time consuming. So sometimes if you think you're running out of time, you might want to leave it to the end and come back. Or do like I've done, maybe draw a little sketch to remind yourself. So then you can just concentrate on drawing it when you come back to do it at the end. And 1, 2, 3. And 1, 2, 3. Okay, so we've got our 4 rectangles. Then we needed the side bits. Now I was doing them off of the base. So 1, 2, 3. 1, 2, 3. Now it doesn't have to be exactly like this. There's other ways of drawing a net of a cuboid, but I think this is just a nice simple way of thinking of it. And we're going to have the same over here. 1, 2, 3. 1, 2, 3. And there it is. Okay. But you saw doing the sketch was very quick, but it just meant that then I could focus on drawing the lines afterwards. Question 8. Layla buys a box of donuts. Each donut is filled with either jam or apple or chocolate. In the box, there are 7 jam donuts, 15 apple donuts, and 18 chocolate donuts. Layla opens the box and picks a donut at random. What's the probability that Layla picks a jam donut? Well, let's think about, well, how many have we got in total? So we've got 7 plus 15 plus 18. So we've got 40 in total. So that's all of our options. We're only interested in the jam ones. So that's going to be 7 out of 40. And we can put that in there. Okay. The probability that a person does not like donuts is 1/10. Which of these words describes this probability? Well, I'm going to do it as a process of elimination. Well, it's not impossible because it's a value, it's a number, so it's not impossible. It's also not certain because for it to be certain, it'd have to be 1 or 100%. Now, it's not even either because even would be like half or 50%. You need the same probability of it happening as not happening. So it's either unlikely or likely. So is it more than half? Well, that would be 5 out of 10. So it's not likely, so it must be unlikely. Question 9. Here is a regular hexagon. So remember, with a regular hexagon, it means that all of the sides and all of the angles are the same. Calculate the perimeter of this hexagon. Well, it's going to be 2.8 plus 2.8 plus 2.8 plus 2.8. Or in other words, 2.8 times 6. .8 centimetres. So trying to check that you know what perimeter means, so going around the outside of the shape, and the fact that it's regular means that they're all going to be the same. Okay. B. Draw a line of symmetry on this equilateral triangle. Well, equilaterals, so all of the sides and all of the angles are the same, so I'm just going to cut it straight down the middle. Yeah. If you're not very good at doing it by eye, you can measure it first of all, and then make sure that you're cutting enough. So look, if I measured this, I'd say that's 3.4 centimetres. So I'd then do 3.4 divided by 2 to get halfway, which is pretty much where I've drawn that 1.7 centimetres there. Okay. Here is a polygon. For those that can't remember, polygon is just a 2D shape that's made with straight edges. One angle is labelled with the letter X. That's this one here. Select the word that describes the angle labelled with the letter X. So I'm going to do this as a process of elimination again. Well, it's not acute, because I know acute is anything that's less than a right angle. Okay. It's not a right angle, because I know a right angle would be something like that. Okay, 90 degrees. So it's not a right angle. Actually, let's cross those out. An opposite angle. Well, opposite angle means something in GCSE, but it's not really something that we look at here, and it's not in the same context. So if you're not familiar with it, maybe think, oh, well, I'll leave it for now, and you can always come back to it. Okay. Obtuse. Now, an obtuse angle is something like this. So it's more than a right angle, but less than 180 degrees. If we look at ours, if we imagine 180 degrees would go through there, this is more than 180, so it's not obtuse. In fact, this one is a reflex angle. Okay, so it might catch you out if you see opposite and think, oh, I'm not sure about that one. That's in there just to try and trick you, try and catch you out. Question 10. Marlon is doing a survey about exercise. He asks 100 people how many times a week they exercise. The results are shown in the table. So we've got 10 people exercise between 0 and once a week, 64 people exercise between 2 and 3 times, 18 people exercise between 4 and 5 times a week, and 8 people exercise between 6 and 7 times a week. Marlon wants to show this information on a graph. Draw a suitable graph for Marlon. So here's our graph paper. Well, I think a nice simple graph for us is going to be a bar chart. Okay, we've got 4 categories on numbers of times, and we've got 4 big squares here. So let's split this up. Oh, this is going to be our number of times. So we've got 0 to 1, 2 to 3, 4 to 5, and 6 to 7. Now we've got to think about our numbers going up here. Well, look at the biggest number, 64. So we've got to make sure that it goes up at least as far as 64. So if we look, we've got 10 in each of these big boxes. If we did 10, 20, 30, 40, well, 64 is not going to fit on. So instead of 10 for each one, maybe if we say, well, what about if we go up in 20s instead? So 20, 40, 60, 80. Yeah, 64 would fit on then. So we're going to have 80 at the top, 60, 40, 20 and 0 down there. So this is our number of people. Now we need to start to plot it. So there were 10 people, shown here, 10 people for 0 to once. So if this is 0, this is 20, 10 is going to be in the middle. I'm just going to draw the tops of the bars for now. For 2 to 3, we've got 64 people. Well, we've got 60 on the grid. Now, we don't want to count up 1, 2, 3, 4, because remember, each of these little boxes doesn't count for 1. Well, how much do they count for? Well, halfway would be 70. So to get from 60 to 70, we've got 5 boxes. So each of them must be worth 2. So we'd have 62, 4, 66, 68, 70. So 64 is going to be this one here. Then for 4 to 5 people, 4 to 5 times, we've got 18 people. So 20 is down here. And remember, if each of these little boxes is worth 2, 20 minus 2 would give us 18. And finally, 8 people exercise between 6 and 7 times. So again, here was 10. Go down 2. That must be 8, must be there. And then I can just claw my bars in. Your bars don't have to touch, but mine touch, so I don't have to draw so many lines. Okay, and we can just do a little title. We can call it exercise frequency or something like that. Okay, on to our last question. Question 11. John is tiling a swimming pool. He needs to buy 120 boxes of tiles in total. He buys boxes of blue tiles and boxes of white tiles in the ratio 1 to 4. So that means every time he buys 1 box of blue tiles, he buys 4 boxes of white tiles. Each box of blue tiles costs £23.99. Each box of white tiles costs £16.75. Work out the total cost of all the tiles John needs. You must show your working. So we've got a ratio question. So we're going to draw a ratio table. So the ratio that we're given is blue to white is 1 to 4. So I'm going to put in a total column. So if this is all we had, 1 blue and 4 white, we'd have a total of 5. But we're told he actually needs to buy 120 in total. So we put that on our new line. Well, how many lots of this first row do we need to get up to 120? Or in other words, what's 120 divided by 5? It's 24. So that means we're multiplying 5 by 24 to get up to 120. So we're going to need to do the same to both of these. Okay. Well, 1 times 24 is going to be 24. And 4 times 24 is 96. And you can do a check here as well, because if we add the 24 and the 96, or 96 and 24, it should give us 120, which it does. Right, so now we can start to work out the cost. We've got 24 boxes of blue tiles, and they cost £23.99 each. So 24 times £23.99 gives us £575.76. Now for the white tiles we need 96 boxes of those, and they cost £16.75 each. So 96 times 16.75, that's £1,608. Okay, so what's the total cost of that? Well, we've already got the 1,608 in there. Let's add back the 575.76. And we've got a total of £2,183.76. And that's the end of the calculator paper. Okay, so I hope you enjoyed that, or found it okay. Enjoying might be going a bit too far. But do like the video, subscribe to the channel, make sure your notifications are on, add any comments, and look forward to seeing you again soon. Thank you. Right.